Okay, this is 2019 question 7 to my knowledge, and let's give it a go. So, ft is minus 4t squared plus 16t plus 1. Now, at what height was the ball when it was hit by the goalkeeper, right? So if you throw this into the table function in your calculator, it will sort of explain what the full question means. Instead of using t, use x. Now remember, the deal is with time is that time has to start at 0 seconds. There is no such thing as negative time. So t would start at 0 seconds. This means I have to start x at 0 seconds as well. So start from 0, argument's sake, I'll go all the way up to 10 seconds and a step of 1. Look at these numbers, 0, 1. That basically means that at time 0, the ball is 1 meter in the air. And if you keep going all the way up, you can see that at 2 meters, it reaches a height of 17 meters. Okay? And then after a couple of seconds, see somewhere in between 4 and 5 seconds, at 4 meters, it's back at 1 second. And at 5 meters, the ball is basically minus 19. Now, let me explain why minus 19 makes no sense. If you're a goalkeeper and you kick a ball in the air and it goes all the way up to, what is it? It goes after 2 seconds, it goes all the way up to 17 meters in the air. And then at 4 seconds, sorry, at 0 seconds, it's 1 meter in the air, which means the ball is in your hands. Now, at ground level is a height of 0. And basically, you can't go to minus 19 because that means the ball burrows into the ground and goes directly underneath 19 meters into the ground, which simply isn't going to happen. Okay, so just remember that's what these numbers means. Now, the first question is quite simple. At what height was the ball when it was hit by the goalkeeper? At what height was the ball at t equals 0? Grab your equation and replace all t values with 0. And you already know this answer because you know that the height has to be 1 meter. Now I'm just going to replace this. See, ft is the height of the ball, so ft can just be replaced with the letter h. This means the height is 1. Complete the table below to show the height of the ball at various intervals. Okay, so I actually already have this, but you notice that the gaps are 0.5. So I'm going to reduce my interval or my step to 0.5. And then I have all these numbers now. So 0, 1, 0.58, 113, 1.5 is 16, 2 is 17. 17 is definitely the 17 is definitely the highest part because it's symmetrical either side. See the way they're both 16s on either side? That means 17 is definitely the maximum on that one. And then we have 3 is 13. That's going to be 8, and that's going to be 1 because I know it's going to be symmetrical on both sides. Happy days. All right, let's move on. Now, oh, I'm going to draw this. Nothing like a good graph to get you going. Now, here we go. Okay, and I need to grab these points from the previous graph. So, unfortunately, it's not all on the same page for me, so I need to grab this and copy it. Put on the same page, reduce its size, copy and paste. Okay, let's do this. Bring it across. Whoop. There it is. Okay, and I am going to have this here, ready to go. All right, let's draw this graph. 0, 1. Here we go. 0.5 and 8. So 0.5 and 8. 1 and, what is it? 1 and 13. 2 and 17. 2.5 and 16. Sorry, I should have put in the 16 here and here. And then it's all matched up. And then 4, 1. This, right? So the graph goes something along the lines of this. Symmetrical graph, like so, and we're good to go. Now, find Find the length of time the ball's in the air from the time it hits. So using your graph. So in a way, we're sort of estimating when it hits zero again. And I'm taking around the 4.1 mark. But the beauty about the calculator is I don't have to estimate that. I can go in between 4 and 5. And I can do sort of like start at 4, end at 5, go up a difference of 0.1. And look what I can do here. 4.1, 4 is on 1, and 4.1 it was on 0.64. So somewhere between 4 and 4.1 across the axis. So 4.1 is a decent estimate. So you can say across that t equals 4.1. Okay. That worked out pretty well. Okay, let's go to D. The length of the ball was 10 meters or more above the ground. All right, so 10 meters or more above the ground, you go to the height of 10, you draw a line straight across. Where it hits the graph, you go straight down. These two times here. I estimate that's 0.5, so I'm thinking that's 0.6. And that would be 3.5, so I'm thinking that's 3.3. So I'm going to do 3.3 take away 0.6. Okay, so 3.3 take away 0.6, and that will be your 2.7 seconds. Okay, because realistically, it's this time here. It's above 10 meters in this time frame here. And this time frame here is in between 0.6 and 3.3, which, as we said earlier, is a width of 2.7 seconds. Okay. Now, finally, the derivative. Find ft, the derivative of this function. Absolutely. Bring the 2 to the front, multiply by the minus 4, and get minus 8t. Take 1 away from the power, 8t. Differentiate 16t, and you just get 16. Differentiate 0, you get 1. And that'll be f dash t. Use your answer from D part 1, so this answer right here, to find the speed. Now, as I discussed recently, if the original equation is height or distance, the first derivative is speed. And I told you to use the first derivative in the air for 4 seconds. So you're going to use a t value of 4. So your speed equals minus 8 times your time plus 16. And your time in this question is 4 seconds. So it's minus 8 times 4 plus 16, which is minus 32 plus 16, which is minus 16 meters per second. Now, the reason for that is it's on its way down. So it's on its way down after 4 seconds. That's why it's going minus 16. If it's on its way up, it'll be a positive number. But when it's on its way down, it's obviously a negative number. Use your answer from D part 1 to find the value for which the ball was descended. Use your answer of D part 1 to find the value of t for which the ball was descending and traveling at speed. Alright, so essentially, speed equals descending means minus 8. Ascending would mean plus 8. So speed equals minus 8. And we know the formula for speed is minus 8t plus 16 equals minus 8. So therefore, it's minus 8t, bring the 16 over the other side. It goes minus 8 minus 16 is minus 24. And then t value is minus 24 divided by minus 8. That'll be a t value of 3 when it's descending with a speed of minus 8.